Hello, everybody. Here with another example of curvilinear motion using the r theta radial and transverse coordinate system. So here we have a typical example of a cam follower. So this is the cam here, which is rotating, as you could see, at a constant rate of 150 revolution per minute. So that's actually theta dot, which is given. We're going to convert that in a minute to radians per second. And then, as you could see, this follower, which is this ball here, kind of compressed by this spring here, right, is following the profile of this cam. And basically, the follower is constrained within this, slot in this rod AC, and it's rotating basically at this constant rate of 150 revolution per minute. The profile of the cam is given by this equation, 2.5. So R, which basically gives you the profile of the cam, it's 2.5 plus 0.5 cosine 3 theta. And R is going to be in inches here in terms of the units. Okay, so what are we trying to find when theta equal 10 degrees, which is this more looks like 30 degrees or so, but when theta equal 10 degrees, which is basically means the rod is here somewhere, we want to find the magnitude of velocity and the magnitude of acceleration. So remember, based on what is given to us, we are trying to use the r theta coordinate system. So it's more convenient to use that, even though we could actually go to x, y, and in a way also to nt coordinate system and use that. And we can go between the coordinate system as well. So how are we going to approach this problem? Recall that for velocity, and you have this in another video, there are two components of velocity. Radial component is r dot, and the transverse component, theta component, is r theta dot, okay? Similarly for acceleration, if you want to find acceleration, there are two components of acceleration, the radial component, which is r double dot minus r theta dot squared, and the transverse component is equal to r theta double dot plus 2r dot theta dot. So yeah, for a second, sorry, I pressed the wrong button and I lost the sharing with you. Okay, so then the magnitude of velocity would be square root of VR squared plus V theta squared. As always, if you have two perpendicular components, you can find the magnitude by taking the sum of the squares and then take the square root. And similarly, the magnitude of acceleration would be AR squared plus A theta squared under the radical. All right, so what we need then is the R dot, R dot, R double dot, and theta dot, which theta dot is given. It's just that we have to change the unit. And basically theta double dot. Now I have to tell you that theta dot here, 150 RPM, as you know, we need to do, so that's revolution per minute, right? So we multiply by 2 pi, so 2 pi radians is 1 revolution. And then let me just remove this. So over here, so I can fill in. Okay. So, and then 1 minute is 60 seconds, right? So basically you just have to multiply by 2 pi and divide by 60 if you want to convert from revolution per minute, RPM, to what? To radians per second. So that becomes 5 pi radians per second, which is about 15.71 roughly, if you round it a little bit. But remember, this is rotating at a constant rate. So theta dot is constant. So therefore, theta double dot, which is the derivative of that angular acceleration in a way of this rod, is going to be 0, which is going to be useful or makes our life a little bit easier, or calculation a little bit easier. All right, so let's go ahead and start with R. So R, and by the way, let me just kind of give you an idea of what the radial and transverse components are here. So radial component basically is the extension of the R. So this is the R axis, and theta axis, that's where the particle is. Theta axis is perpendicular to that. So that would be the theta axis right here. If I could draw this without doing a lousy job. So that's a theta axis, 90 degrees to that. Okay. So what we mean with the radial axis and transverse axis. Okay. So now we are ready to actually figure out what is R, what is theta dot, or R dot, and R double dot. Just what you have to be careful, guys, is that if R is 2.5 plus 0.5 cosine 3 theta, R dot is what? R dot is dr dt. So that is actually, you have to take the derivative of R with respect to theta, and then you have to multiply that by the derivative of theta with respect to time. So you see how that's actually equal. So this is something that people forget when they take the derivative. This is derivative with respect to time, not theta. Yeah, this part is derivative with respect to theta. So if you go ahead and do this, derivative with respect to theta, well, the first term is just a constant. So we end up getting minus 1.5 sine 3 theta. So you have it 3 times, right? 0.5 and so on. Derivative of cosine is negative sine, right? But the term that is some people forget is the theta dot, d theta dt. So that's R dot. Similarly, R double dot would be the derivative of R dot. So we could actually go ahead and factor the minus 1.5, and then we have to use product rule. So derivative of sine 3 theta is what? It's 3 cosine 3 theta times theta dot, derivative of the first times the second. So you have another theta dot here, right? And then the first, which is sine 3 theta, times the derivative of the second, which is theta double dot. Now, fortunately, theta double dot is 0 because theta dot is constant, right? So now go ahead and plug in what we have, meaning plugging the theta and theta dot, and calculate this. So if you go ahead, let me just show you the one, and then I'll give you the rest of them. So that's 2.5 plus 0.5 cosine of 3 times, remember, you want to do this calculation at what, theta equal 10 degrees. So that would be cosine 30. So if you do the calculations, R should come out to be about 2.933 inches. Similarly, R dot is just a plug-in. So theta dot is this 15.71, and then just put the sine 30 here, which theta equal 10, so it becomes sine 30. So R dot comes out to be minus 11.781. Remember, its unit should be inches per second. And similarly, R double dot, which is this expression here, basically. Remember, the second term is 0 because theta double dot is 0. Happens to be minus 961.574. The unit should be inch per second squared. So now we are ready to do our velocity calculation and acceleration calculation. So recall that I had it a minute ago up here. Velocity has what? 2 components, R dot and for V sub R, and V sub theta is R theta dot. So V sub R is R dot, which is simply this guy, minus 11.781 inches per second. And V sub theta is what? R theta dot. So go ahead and multiply R, which is 2.933 times theta dot, which is what? 15.71. So V sub theta comes out to be 46.1 inches per second. So now you have the 2 components of velocity. Remember the magnitude of velocity. If you want to, by the way, write this vectorially, you would write it like this: two components, the radial component along the radial unit vector u sub r is the radial unit vector, and 46.1 u sub theta is the transverse unit vector. But anyways, the magnitude, as I showed you earlier, is the square root of sum of the components squared. So minus 11.781 squared plus 46.1 squared. This happens to be 47.6 inches per second. So that's the magnitude of velocity of that follower at theta equal 10 degrees. So kind of give you an idea, even though this is not really the 10 degrees. Let me see if I could show this to you. So radial component is what? Negative 11.781, and transverse is 46.1. So this is the positive R. So we have a component of radial in this direction and a component of much larger in the theta direction. So this is in a way V sub R, this is V sub theta, and what I just determined for you was the V. Now, if you draw this carefully, this velocity here has to be tangent to this profile. Velocity by default is always tangent to the path. So if this is the profile of the cam, that's the velocity, tangent to the path. Okay, so now you have an idea how we have to do the acceleration. Remember, there are two components of acceleration here, right? Radial and transverse, right? So go ahead and just plug in, do the plug-in. So let me go back to black. So A sub R is what? R double dot minus R theta dot square. So go ahead and just plug in these numbers, right? And I'll give you the final outcome, minus 1,685 roughly inches per second squared. And A sub theta we say is what? R theta double dot plus 2R dot theta dot, right? Just do the plugin. Remember, this actually becomes 0, right? Because theta double dot is 0, because theta dot is constant. Okay, this comes out to be minus 370.1 inch per second squared. Again, magnitude of accelerations is square root of AR squared plus A theta squared, and you know the rest of this. So A comes out to be, magnitude would be 1,725 inches per second squared. So just again give you an idea. So if this is our radial axis, remember this is the 10 degrees, so this is more like it, right? And this is where the follower is. This is our theta axis. And what I just determined for you is, if I could draw this with a different color. So the radial component happens to be much larger. So let's say this is your 1685, and see how it's pointing in the negative direction. Remember, this is positive R. And negative theta is also here. So this is the transverse, let's say. So this is radial and this is transverse. And the magnitude of acceleration that I just calculated for you would be then this guy. Remember, acceleration in general, so if say this is the profile of the cam, right? Right, part of that profile, right? Acceleration in general is not what? Tangent to the path. It could be tangent to the path, but at the inflection point only. All right, so as always, guys, thanks for watching my videos, and if you like it, please press the like button and subscribe. And I'm always making different videos on different topics: mechanics of materials, vibrations, statics, and so on. So thank you for watching and listening.